What do you expect to find water? Solid, liquid, or gas at this temperature?
Liquid.
Water below zero, below that temperature, water is solid ice. It's impossible to find water below 0 degrees liquid. It must be solid. When the temperature of water reaches 0 degrees Celsius, it starts to melt. If the temperature becomes 1, the melting becomes faster. 2, faster and faster. 3, faster and faster, and so on. But the beginning of melting, this process, melting of water, starts at this temperature. But it doesn't mean that it is the single temperature at which water melt. ما بعرف فاهمين يا شباب هاي الشغلة؟ Do you understand this point?
Yeah.
Yes.
Okay.
Yeah.
Right. Each substance, you have to know that each substance, not only water, iron, copper, gold, any substance has its own melting point and also has its own freezing point. And this melting point can be used to identify a material. Type, particle changes. Also, please hold on. Particle changes, as we know that all matter is made up of small particles, very small particles that we can see them with our eyes and even with powerful microscope. These particles, anything in this universe, in this world, is made up of particles. In this paragraph, or in this page, we are talking about two things: evaporation and boiling. Evaporation and boiling, in both of them, the water or the material or a substance changes from liquid to gas. This how are evaporation and boiling like? What is common between evaporation and boiling? In both cases, evaporation or boiling, water or the liquid material change, the liquid change to a gas. Understood? But there is, of course, a difference between evaporation and boiling. Can anyone give me one difference between evaporation and boiling? Can anyone tell me or give me one difference between evaporation and boiling? Okay, Sabine. Sabine.
Mr. Evaporation, when
Okay.
you boil something and goes up to the atmosphere,
Again.
is when we boil something. Can you hear me?
طيب Sabine, continue.
Is when you boil something, such
Okay.
as yesterday, give that an example. How do we, when we have a water and salt,
طيب.
how do we separate them?
Okay, but I'm not talking about how to separate a mixture or a solution. Okay. طيب. What do I ask? My question is, how are they different?
Can I?
طيب Tala, thank you Sadine. By the way, Sadine, thank you very much. Tala.
Boiling happens all through the liquid and evaporation from the top.
Okay, or thank you. This is the first difference. Evaporation, particles evaporate from a liquid when they are at the surface. Please, this is a very important point. Please, evaporation starts or happens at the surface of the liquid. Particles that are at the surface of the liquid evaporates. Then particles below them. Type. These particles that at the surface are evaporate and are moving upward with enough speed. Type. Now, boiling happens through the liquid. Okay? Where is it? I'm looking for this point. If the temperature of a liquid is high enough, particles will change to a gas not only at the surface, look, not only at the surface, but also throughout the liquid. And this is boiling. In boiling happens throughout the liquid. There is also another difference between evaporation and boiling. Evaporation happens at any temperature. By the way, did you know that water can evaporate even when it is cold? For example, 5 degrees Celsius, the temperature is very low, but evaporation can happen at 5 degrees Celsius. Evaporation can happen at any temperature, but boiling has a specific temperature. For water, what is it?
100
100 degrees.
Celsius.
By the way, any substance, not only water, has its own boiling point. Okay, of course, for iron, for example, it's very, very high. I think thousands of more than, I don't remember the boiling point of iron, but it's very close to 2000 or more. But for example, for water, it is 100 degrees Celsius. So you have to know that boiling and evaporation, both of them, the matter change from a liquid to a gas. But evaporation happens at the surface, while boiling throughout the liquid. Evaporation is slower than boiling. Boiling happens at a specific temperature, while evaporation can happen at any temperature. Is it clear? Right. So, if the temperature of a liquid is high enough, particles will change to a gas not only at the surface, but also throughout the liquid. This is that's what we mean by boiling. As a gas particles move quickly upward through liquid, bubbles of gas form under the surface of the liquid. You can also, if you look at the water, how do you know that the water is boiling now? By seeing bubbles. Okay. The boiling point of a liquid is the temperature at which this occurs. So boiling point happens when the particles of the liquid start. Boiling point happens when the whole liquid or whole particles of the liquid start to go to gas. As with melting point, each substance has its own boiling point. For water, it is 100 degrees Celsius, and we can use this property of matter to identify it. Okay, we can use the boiling point to identify the type. Also, we forget to mention something important, that both of them, evaporation and boiling, are physical changes. Understood? Boiling, a physical change. Evaporation also is a physical change. We finished lesson 2. Lesson 3 is talking about chemical changes. What is the difference between physical change and chemical change? In a chemical change, simply matter, we have new substances. A chemical change, turn to page, which page is it? 7, sorry. This is page 64. In a chemical change, or a chemical change is a chain that produces one or more new substances. Here, in a chemical change, we have a new substance, or more than a new substance. This is an example of chemical change: burning. When you burn charcoal, when you burn a paper, when you burn anything, burning is a process. For example, in any process of burning, the material combined with oxygen in the atmosphere, and the new substances are formed like ashes and gases. Okay, in burning, okay, in burning we have new substances, ashes and other gases. Okay, here this charcoal is no longer after burning. It's no longer charcoal. It changes to something else, to ash and other gases like carbon dioxide. Okay, so the composition of the matter changes. In a chemical change, the identity of matter changes. Okay, burning is one example of a chemical change. Also baking a cake or baking a bread. Also, these are chemical changes. What happens to the particles of matter in a chemical change? When a chemical change occurs, what happens to the particles that make up the original substances rearrange in a new way to form new substances? Okay, what happens? The particles of matter, suppose that we have substance A and substance B, in a chemical change, their particles rearrange to form new substances like this. So, for example, if we have AB, these are the original substances. For example, A combined with D and substance, and D combined with D substance, like when you the same thing for the logo. Okay. This is also another example of a chemical change, rusting. In a rust, by the way, is a compound. It is made up of iron. When oxygen from the air combine with iron, okay, they form a new substance called iron oxide or rust. Okay, rust is completely different from iron and oxygen. We have here a new substance with different properties. So rusting, burning, all of these are examples of chemical change. In conservation of matter, in any kind of change, physical or chemical, mass is always conserved. This is called the law of conservation of mass or the law of conservation of matter. This law states that in any chemical change or physical change, the total mass of the matter does not change. If you start, for example, if you start with, again, let's back to this example, last thing. Here, for example, suppose that each particle has a mass 4 grams. The orange particles, each one of them has a mass of 4. So here we have 16 grams. Suppose that the mass of each red particle is 1. So we have 1, 2, 3, 4, 5, 6. So 6 plus 16, the total mass of the substances, iron and oxygen, before the chemical change will be 22. 16 plus 6 means 22. After the chemical change, when the chemical change happens, the total mass of the new substances must equal the total mass of the original substances. So the rust here, the mass must be 22, according to the law of conservation of matter or law of conservation of mass. That means mass or matter never created or destroyed, or never gained or lost. Understood? Right. This is the law of conservation of mass or the law of conservation of matter is correct or applied to both physical and chemical changes. The same thing here. Also, the chemical change is also called a chemical reaction. So chemical reaction or a chemical change have the same meaning. This is everything about, okay, Another example of chemical changes, many chemical changes happen in the kitchen, like what like many things, many chemical changes can happen in the kitchen. Okay, to make this process is called changes happen in the kitchen all the time. A chemical change occurs when a chef makes fresh cheese. To make fresh cheese, the chef adds lemon juice to whole milk. Okay, so when you want to make a fresh cheese, this is a chemical change because you start with different substances and end with new substances. Okay, this is how to make fresh cheese. This also process when this coin, after a long period of time, this coin is made of copper. After a long period of time, when it combines with oxygen, it changes to a green substance. Okay, this green substance is called carbon dioxide. This is also a chemical change. This is everything about chemical changes.
Mr.
Okay,
Mr.
أيوة.
Up. Can you go up? But
Talk please. يلا احكي مين اللي بده يسأل؟ أسد؟
Sadine.
سدين. اوكي سدين تفضلي.
Is this important? The lesson 3 check at page 73.
73. Yes, of course, important.
Important?
Did I send you the answers?
No.
طب I will send you the answers. But the last lesson in topic 2, it is solutions, mixtures and solutions. You have to distinguish between a mixture and a solution. Mixture is a combination of 2 or more substances. A mixture in different materials are placed together, but each material in the mixture keeps its own properties. Example of mixtures, for example, nut and raisin mixture, or a bowl mixed nuts. All of these are mixtures. So it is a combination, or different materials are added together. In a mixture, different materials are placed together or added together, but each material in the mixture has its own properties. And it is generally very easy to separate the mixture. Okay? Different parts of the mixture can be separated from the rest of the mixture. Okay, for example, sand and the blocks. When you mix them together, you can easily pick the blocks, or you can separate it easily. There are many ways to separate mixtures, by filter, by using many ways you can separate mixtures. But some mixtures can be separated as easily as the nuts and raisins. You can pick nuts from raisins or raisins from nuts. Also, iron rock, iron ore can be separated. Okay, طيب. Solution, the difference between a solution and a mixture. Solution is a type of mixture. So solution is a mixture, but the substances are spread out evenly and do not settle to the bottom of the container. In general, the particles or the components of a solution are spread evenly. They are evenly mixed, and it is much harder to separate the solution. Example of a solution: sugar water solution, salt water solution. Okay, you have to know that all solutions are mixtures, but not all mixtures are solution. Okay. In this separating solutions, we can, for example, this solution of sugar and water or salt and water, we can separate it by using the physical properties. We can evaporate or boil the water. The sugar or salt will left behind. Okay. Here, this is very important point to distinguish between mixtures and solutions. Remember that all solutions are mixtures, but not all mixtures are solution. So, for example, a mixture of raisins and nuts, it's a mixture. I can't say that this is a solution. But sugar water solution, I can say that this is a solution and also this is a mixture. Okay. This is everything about lesson 2, topic 2. I think, inshallah, that it's very easy. It's very easy. Let's go. There is no time because I have another meeting. I want to end the meeting. Don't worry about the exam, inshallah. I think that it is very easy, especially if you study well. If you study well, inshallah, you will get a good mark. Okay? Right. So let's topic two. The lesson 1, you have to know to distinguish between the solid, liquid, and gas. In lesson 2, you have to understand what is a physical change, and it doesn't. In a physical change, no new matter is formed.
هذا الامتحان topic 1 و topic 2.
لا, topic 1 and 2. But Ghassan, we don't have enough time to memorize topic 1. And I didn't revise, or I don't revise with you topic 1 because we already have a quiz in the last week. And I think that you still remember topic 1. Okay, so our exam will be in topic 1 and topic 2, please. Our exam in topic 1 and topic 2. Right, thank you for listening. I want to end the meeting. If you have any comments, any questions, please send me by WhatsApp. Thank you. Goodbye.
Bye.
Goodbye.
Bye.
Goodbye. See you, inshallah.